In this lesson, we'll be discussing atomic radius and its trend in the periodic table. Now, the atomic radius of an element is more difficult to define than you may think. Because electrons are constantly moving, there is no set outermost shell that can be measured. Instead, we focus on where the largest electron densities are found, meaning where electrons are most commonly found. Thus, the atomic radius is best defined as the average or typical distance from the nucleus to the maximum electron density of the highest shell. For example, let's say we were looking at a lithium atom. Lithium has an electron configuration of 1s2, 2s1. The atomic radius of the lithium atom would then be the distance between the nucleus and the maximum electron density of the n equals 2 shell. Now, it's next to impossible to measure the size of a single atom, so the atomic radius of an atom is generally determined by measuring the distance between two nuclei in a certain environment. For elements that form diatomic molecules, meaning two atoms of the same element bonded together, the covalent radius is generally used in measurement. This involves taking half of the length of the diatomic bond. A second way to measure the atomic radius of an atom is to take the metallic radius. This is taken when atoms are joined by a metallic bond. Similar to the covalent radius, the metallic radius is measured as half the distance between adjacent nuclei. Now, in the periodic table, the atomic radii of elements decreases across a period from left to right and increases down a group. It decreases across a period from left to right because when moving across, you are both increasing the number of protons as well as adding electrons into empty spots in existing shells. Since electrons within the same shell don't shield each other from the proton's pull, the increased number of protons draws the electrons closer to the nucleus. When going down a group, however, electrons are added into new shells. These new shells have maximum electron densities farther and farther away from the nucleus.